Today we're going to do section 11.6, which is sums and difference of radicals. Before we get started with the radical portion, let's do a quick review. Remember when we worked with adding different variables, we could only add variables that had the same signs. And remember when we added these variables, we used the distributive factor by pulling out the numbers in front and then combining them with the variable. We're going to do the same thing when we deal with radicals. So here we have the square root, 2 times the square root of 7 plus 5 times the square root of 7. We can go ahead and add these together because they have the same radical. And now we're going to go ahead and pull out the coefficients in front of them, the numbers in front, add those numbers, so 2 plus 5 is 7, and then we attach the radical, which is basically, we can think of it as our variable in a sense if you want to. So our final answer would be 7 times the square root of 7. The same thing we're going to do when it comes to subtraction. So we can only subtract radical signs that have the same number underneath it. And we're going to go ahead and pull the coefficients out and just do what the sign tells us. So we have 2 subtract 5, which our answer is -3. And then we attach the square root of 7. Okay, so let's go ahead and let's see how this works here. So remember, I can only add radicals that have the same sign. So I need to go through here and find which ones have the same, and I notice it's the square root of 7. So I'm going to go ahead and combine them, take the coefficients in front and do the 6 minus 2. There's my square root of 7 that's attached to it. And then I have to have this plus 3 times the square root of 2. This has nothing that I can combine with it, so it kind of hangs out on the back. And we will write that once I do my final answer. So do our math here. 6 minus 2 is 4 times the square root of 7. And then there is my plus 3 times the square root of 2. I cannot combine them because they do not have the same square roots underneath it. Actually, the same radicands underneath it. So that would be my final answer. Okay, let's take a look at this one here. Now I have 4 times the square root of 2 minus 3 times the square root of 5 plus 2 times the square root of 7. If you notice, there is nothing in common. None of these numbers underneath the square root sign is the same. So I have to leave it as is. I can't do anything with it. Okay, so let's do some practicing here. They want us to simplify the following radical expressions. So here's my 2 problems. Okay, very first thing we always double check is, do they have the same numbers underneath the radicand sign? And they do. So I'm going to go ahead, add the numbers in front, which would be 5 plus 1, and then attach the square root of 3 symbol, do the math, and my final answer is 6 times the square root of 3. Okay, same thing for here for subtraction. Double check, do they have the same number under the radicand sign? And they do. So I'm going to go ahead, separate the numbers in front. So 5 minus 2, attach the square root of 6, complete my math, and my final answer is 3 times the square root of 6. Okay, so let's go ahead, and that's pretty straightforward. Now we're going to make it just a little bit more complicated. I don't think we need to do these extra problems. Looking at them, notice this one, does it have the same number under the square root? No, so we cannot combine that. This one here, we have 3 problems together. Let's do this one quick before we get moving here on to the next section. First thing, do we have the same number under the square root symbol? Yeah, the square root of 2. So I'm going to go ahead and combine these numbers. I have 2, and this is subtract 5 times the square root of 2. This 3 to the square root of 5, whoops, there needs to be a 3 in front of here, needs to hang out in the back. Okay, do my math. Positive 2 subtract a negative 5, or sorry, add a negative 5 gives me a negative 3. And then I have 3 times the square root of 5. That there is my final answer for this whole problem. Okay, so now let's make it a little bit harder, not much. Now take a look here, okay? We have a problem here, 2 times the square root of 12 plus 8 times the square root of 3. I don't have a common number underneath the radicand sign here, okay? And so first things off, you're going to want to say, oh, I can't do anything with it. Well, we can, because we need to simplify that. We know the square root of 12 can be broken down into its factors. And when I do that, I will find that I end up with a square root of 3 symbol. So remember how we do this is we find what perfect square goes into it, and we're looking for a factor of 3. And I know right off the bat that I can break this apart into the square root of 3 times 4. Okay, rewrite this here. I can take the square root of 2, which ends up being 2 times 2 times the square root of 3, which is 4 times the square root of 3. Now I have numbers that have the same number under the radicand sign. I can go ahead and add them. So my final answer here is going to be 12 times the square root of 3. Okay, so let's do some more practice with this here. Okay, get this all situated here. The next problem we have is square root of 27 plus the square root of 12. Okay, remember we're looking for perfect squares in this, okay? So what perfect square is in 27? We know 9 times 3. Okay, so I'm going to separate it into these two. Take the square root of 9, which is 3, and I end up with 3 times the square root of 3. We're going to do the same here for the 12. We just did 12. Remember, it's the square root of 4 times the square root of 3. Once I take the square root of 2, I get 2 times the square root of 3. Now, if you notice, they have the same sign. So I'm going to go ahead and add the coefficients in front. And my final answer here is going to be 5 times the square root of 3. Okay, here written down, I'm going to show it to you. This is the other way that we talked about for the other lesson, where I can take my prime factors and simplify it that way. It's whichever way you are more comfortable with to simplify this. If you want to go ahead and find the prime numbers and group them by 2's and then take the square root of it, that is fine. Or whether you want to find the perfect square. In the end, you end up with the same answer. So it's more, what are you more comfortable with to simplify these down? Okay, so let's go ahead, and I have this example here. It's long. Don't let that scare you. There's a lot of numbers here that we need to simplify. And so to do that, we're going to find the perfect squares that go into all of these numbers, okay? So is there a perfect square that goes into 8? Yeah, 4, okay? We're going to simplify that down. How about 18? We've got 9, a perfect square that goes into it. We've done 12 number times, so we know it's going to end up with 2 times the square root of 3. How about what perfect square goes into 50? That would be 25. So once I go about, I have them separated into their perfect square factors. Once I take the square roots of them, I end up with this. Okay, now that I've got those simplified, now I'm going to look for the numbers that have the same numbers under the radicand sign. And so I'm going to group them together. If you notice, it's the 2's here. So I have 6, there's my minus 6, and then I have this 20 way down here. This negative 2 times the square root of 3 has to hang out in the back here. There's nothing that I can combine it with. So now I'm left with just doing the math, and I end up with 20 times the square root of 2 minus 2 times the square root of 3. That is my final answer. That is the last thing I can do to simplify it. Okay, so let's do some examples here and see if you can do it. Okay, so we're starting off with square root of 8 minus the square root of 72. Okay, we're looking for perfect squares that go into it. And I know I have 4 times 2. And I end up with 2 times the square root of 2. Okay, now I need to find what perfect square goes into 72. Okay, 72, I could do 8 times 9, which is 72. I can get there. It'll take me a little bit longer, or we can find another perfect square that goes into it. Let's double check. Does 16 go into 72? So off on the side here, we're just going to go ahead and divide this out and see if anything. 3 is 18. Oh, whoops, we got to go a little bit higher. Let's go. My brain is, let's do 7. 6 times 7 is 42. 7, 8, 9, 10, 11. Oh, way too large. Okay, so I am thinking, let's try again. Does it go in here at all? 5 is 30. 5, 6, 7, 8. Okay, it is not going to go in there perfectly. So let's go ahead and break it down and see what we can do. Sometime it's going to take a little bit longer, and that's okay. So let's do, we know 8 times 9 is 72. When I take the square root of that, I end up with 3 times the square root of 8. Now I know a perfect square is an 8. So I'm going to go ahead and simplify this. I'm going to bring down my 2 times the square root of 2. And then break it apart. So I have 3 times the square root of 4 times the square root of 2. And I end up with, remember this turns into 2. They're side by side. So I end up with 2 times the square root of 2 minus 6 times the square root of 2. Okay, now I have the same numbers. So now I can do the math here. 2 minus 6 times the square root of 2 leaves me with negative 4 times the square root of 2. Okay, so it took a little bit of work. Let's say you can't think of that perfect square that goes into it. That's okay. It might take us one extra step to break down another factor for it, but we will get to the same answer. So don't let that scare you if you can't find the largest square root right away. Okay, let's look at this one over here. Okay, we've got 4 times the square root of 24 plus square root of 54. I'm thinking the perfect square here for 24 would be 4 and 6. Okay, 6 times 9 is 54, so I'm going to do 9 and times 6. Take the perfect square, and I get 4 times 2 times the square root of 6 plus 3 times the square root of 6. And now I can go ahead and add them together because they are the same again. 8 plus 3 is 11, and I got the square root of 6. Okay, this last one here. Okay, it's larger. Don't let it scare you. Let's finish it up. Let's find our perfect squares. So we've been working with 12 again, and we know it's 4 times 3. That, once I take the square root, turns into 2. So I end up with 3 times 2, which is 6 times the square root of 3. Now let's work with our 8, and we know it breaks down into the square root of 4 times 2. Once I take the square root of that, it turns into 2. So 2 times 2 is 4. And let's do this last one over here. We've got square root of 32, which we know is 16. And once I take the square root of 16, I get 4. So 3 times 4 is 12 times the square root of 2. Okay, if you notice, these are the ones that have the same square roots, so we can go ahead and work with that. We're going to go ahead and do 6 times the square root of 3. And now let's do our math here. We end up with negative 4 plus 12 times the square root of 2. That ends up being positive 8 times the square root of 2, and we need to attach that 6 times the square root of 3 in front. And that's our final answer. Okay, guys, you are comfortable from the other lessons with how to find these factors. Like I said, you can go ahead and use the prime ones if you're comfortable or looking for the perfect squares. Once we simplify them, then we can go ahead and do the addition and subtraction as long as we have the same number under the square root sign. If not, they have to be left alone and we can only combine what we can. If you have any questions, go ahead and email me or text me. Have a good day.